Hi everyone, I'm Saili and this is the presentation for our project which is Data Storage and Interface for Processing. We are a team of 3 members which involves Devesh, myself and Yochan. The problem that we have aimed to solve with our module basically involves providing users with an interface to search for various research papers and articles. We have provided users with filters using which they can search for various research papers and articles. The user can search for the items which were published within a given time frame, or the items containing particular title, or also search for various papers and articles that contain the particular keywords, and many more such parameters are provided for filter. We have also provided users with an API to download the corresponding PDFs or BIP files for the papers. Now, this is the tech stack that we've used to implement our module. It basically involves Django framework, uh, which is a MVT framework. We've used Python 3.8. We've used HTML, CSS for the front end and SQLite 3 database engine. We've also used some external libraries such as BibTeX parser for parsing the BIP files, Report Lab for generating PDFs, Beautiful Soup for scraping the PDFs, and the requests module as well. Now let's see the solution approach that we have followed. The implementation is basically divided into 3 parts. The first part involves processing all the BIP files and storing them in the database. To do this, we have created 2 folders, that is unprocessed and processed. The intention behind separate folders is to avoid processing same BIP files again and again. The BIP files that we wish to process must be stored in unprocessed folder. From here, these files are read and each file is processed separately. Each file is parsed using BibTeX parser library, which converts the content of the BIP file into a Python dictionary object. Each element of the dictionary corresponds to the bibliography item in that particular BIP file that is being processed. This object is then stored into the database using Django ORM. In the end, the BIP file is then moved to the processed folder. The second phase involves extracting the items from database based on the filter and search criteria provided by the user. The interface contains various filters and user searches for items using the filters. These filters are passed to the server using request objects. At the backend, these filters are then used to query the database and obtain the expected BIP data. Further, these are segregated into included and excluded lists using the predefined criteria. These lists are then sent to the interface via response object where they are displayed. The phase 3 involves providing user with an API to download PDFs of the items. For this, we have used Beautiful Soup to download the paper. The papers are basically downloaded from Google Scholar using web scraping and then sent to the user via the response. To implement the download of bibliography, we have used Report Lab library to generate a PDF which is then sent to the user via response and display and downloaded. Next, we'll see the demo.
This is the homepage of the project. The user can provide filtering criteria here. All the fields here are not mandatory. Let's see how the filtering works with different kinds of inputs. Initially, let's not give any filtering criteria as they aren't mandatory and just submit the form. Here we can observe that all papers are in the included list and excluded list has no available data. So let us give some some another filtering criteria and check. One thing to note is that a default value for the from field is 0 AD, whereas the default value for the to field will be current year, that is 2020 right now. Suppose we need to retrieve papers from 2003 to 2006 whose titles has keyword Python. The titles of the paper whose bibtex file contains URL are made as links so that the user can go to the URL provided in the bib. Now you can see the original URL given in the bib. For included papers, user can download the PDF by clicking download paper. Similarly, the user can give the quality check feedback by clicking quality assessment check. In quality assessment check, the user can provide feedback for the given questions and then submit them. He can also see the PDF of the paper in the left side. For the excluded list of papers, you can download the PDF of the bib file. This is the bib file of the PDF that has been excluded. Thank you.
So this is the work distribution of our project. The UI and UX was basically totally handled by Yochan, and in the backend, the parsing, querying, and download part was done by me and Devesh. These are the problems that we faced during our implementation. The major part was getting used to the new technologies that we were using for implementation. We took our time to understand the Django framework, which was essential for implementation. Further, from functionality point of view, we faced a problem wherein we wanted to store the entire bibliography item in the database, but we were not able to do so because of the database schema constraints. So to overcome this problem, we decided to save the entire bibliography item as a string in our database. So this way we were able to store the entire data. This was a really good learning experience. Got to learn the working of Django framework, which is a very huge framework. We learned file handling, we learned web scraping, we used Beautiful Soup for that. We also were able to generate PDF using the report markup language, which is provided by the report lab library. Also, some of us got to learn about, get an expertise over Python. So, thank you.